Multi-agent systems fail quietly when state is vague. One agent knows the selected route, another agent found a risk, a third agent writes the answer. Then a retry happens, and nobody knows which facts are safe to reuse. That is why state needs a contract. Shared state is the workflow memory. It stores task identity, durable facts, decisions, risks, messages, and resume points. It is not a transcript dump. It is not every private thought from every agent. It is the small set of information other steps are allowed to depend on. The first distinction is shared state versus scratchpad. A scratchpad is private working space. Shared state is a public workflow contract. A security agent may reason through several possibilities before publishing one risk. A billing agent should not inherit all of that private work. It should inherit the risk that was intentionally written to shared state. This separation keeps agents from accidentally coupling to each other's internal process. It also makes logs safer because you can store durable facts and decisions without storing every intermediate note. In the code, workflow state is the durable object. It has a task ID, the request, route, messages, facts, risks, decision, and version. Agents do not mutate it directly. They return a state patch. That patch says what the agent wants to add or change. This matters because the reducer, not the agent, owns merge policy. Once you use patches, each agent becomes easier to test. Give it a state. Check the patch. Then test the reducer separately. The reducer is where state policy lives. In this lesson, messages append. Facts and risks append but deduplicate. Route and decision are scalar fields, so a later explicit value replaces the earlier one. Those choices are not universal, they are policy. Another workflow might keep all route candidates, preserve conflicting decisions, or require a reviewer to choose between branch outputs. The key is that the rule is visible. Parallel agents are much easier to debug when the merge behavior is deterministic and tested. The checkpointer saves state at workflow boundaries: initial, routed, assessed, and final. That gives you a real resume point after failure. Without checkpoints, retry usually means rerun the whole workflow and hope every agent makes the same choice. With checkpoints, retry starts from a known state version. This is especially important around human review, payment decisions, security decisions, and any step that should not be repeated casually. When you design shared state, start with the fields the workflow truly needs. Identity comes first. Task ID, customer ID if needed, and the original request. Then add durable facts that other steps can depend on. Next, add decisions: route, risk level, selected policy, review status, or final action. These are not chat messages. They are workflow facts. Then add versioning and review reasons. Versioning makes stale reads visible. Review reasons make human handoff useful. Be careful with raw prompts, full transcripts, and private scratchpads. They are tempting because they seem complete, but they make state noisy and risky. Shared state should be the smallest reliable surface that lets agents coordinate. Test state transitions directly. Do not only check the final answer text. Assert that facts deduplicate, risks append, versions advance, and checkpoint history exists. Also test the low-risk and high-risk paths. In the demo, an urgent refund becomes a review decision because the route is billing and the request is urgent. A normal login question can answer directly. The interview answer is this: multi-agent state is a typed coordination surface with reducers and checkpoints. Keep it small, explicit, and testable.